All right, so we just finished adding and subtracting polynomials. Now we're going to talk about multiplying polynomials. So when we multiply polynomials, we're going to multiply each term in one polynomial by every term in another polynomial. All right, and then we will combine like terms. So first of all, let's start with monomials. So here we're multiplying monomials times monomials. So if we look at number 4, and we've actually done this before, right, with our exponent properties. So remember, when we're looking at our constants or our coefficients, we just multiply those like we would normally, right? 3 multiplied by 5 is 15. Okay, and then with the exponents, or excuse me, with the exponential expressions, if they have like bases, then we can use the product rule. So what we can do is add these exponents, right? So I'm going to end up with 1y, and I'm going to add 12 plus 15 and get 27. So that's the final product there, right? 15y to the 27th. All right, let's see number 6. Same idea, right? So I'd multiply the coefficients. Negative 2 multiplied by 8 is negative 16. And then x squared times x to the 5th, since those are like bases, we can add those exponents, right? So 2 plus 5 is 7. All right, and then let's try number 10. So here we have negative 12 and 3 as coefficients. So negative 12 multiplied by 3 is negative 36. All right, and then we have s multiplied by s. Those are like bases. Remember, they both have an exponent of invisible 1, or an invisible 1 as an exponent. So s times s is s squared. 1 plus 1 is 2, right? And then the q, since it doesn't have a like term, it's just going to come down. All right. Number 14. So this we can think of a couple different ways, right? One way is to use the power property or the power rule, and we can distribute this exponent on the outside to all the exponents on the inside, right? Remember, there's an invisible 1 for the exponents that you can't see. So this would be 6 squared x squared, right? So I multiply 2 by each of those exponents, and then I can evaluate 6 squared is 36, and x squared we can't simplify, right? Another way that we could have done that is just multiplied, and you don't have to do both of these, of course, but you could also multiply 6x by 6x, and then 6 times 6 is 36, x times x is x squared, right? So either way, we get 36x squared. All right, number 16. Do the same thing. I'm going to distribute the outside exponent to the inside exponents. So I'll get 3 squared y to the 10th. Y to the 10th is simplified, but 3 squared we can evaluate, right? Remember, don't ever leave constants unsimplified, right? Unevaluated. So this is our final result here.